Hi guys. So when working with some of you in office hours this morning, I realized that I had promised on a homework that I would compute for you gamma of 1/2, and that I owe that to you. So I figure I'll do that, and let's try it by hand. Recall gamma of 1/2 is equal to, by definition, it's the integral from 0 to infinity of x to the minus 1/2 e to the minus x dx. Now, if I want to solve this integral, so my goal is to solve this integral. If I want to solve this integral, the first thing I'm going to do is a weird little trick where I'm going to do a u substitution, where I'm going to let x equals u squared so that dx is 2u du. And so if I do this substitution, what I get out of this is the integral from 0 to infinity, and technically these are x's, but they can also be u's, of, well, u squared to the negative 1/2 is just 1 over u. And then e to the minus u squared, and then 2u du. Which, of course, all simplifies. The u's cancel, and I'm left with 2 times the integral from 0 to infinity of e to the minus u squared du. Now, this is similar to something we've talked about recently, which is if I want to compute this integral, the trick is, so note, that if we instead look at gamma of 1/2 squared, I just got an email. This is going to be the integral from 0 to infinity of e to the minus u squared du times the integral from 0 to infinity of e to the minus v squared dv. Okay? And now, if I want to combine these, I could get the integral from 0 to infinity times the integral from, of the integral from 0 to infinity of e to the minus u squared plus v squared du dv. Sorry, minus u squared plus v squared in parentheses. Right? And now to solve this integral, I'm going to switch this into polar coordinates. And I'm really doing the integral over the first quadrant. So if I'm going to do this in terms of r dr d theta, I'm going to go from 0 to pi over 2, 0 to infinity of e to the minus r squared times r dr d theta. Right? And if I do this out, then, well, what I end up getting here is that this double integral, well, if I do e to the minus r squared, yeah, I'm doing this right. If I do e to the minus r squared times r, I'm going to end up getting a 1 minus the integral from 0 to pi over 2 of minus 1/2 e to the minus r squared evaluated from 0 to infinity d theta, right? I'm doing sort of a u substitution. I don't want to add another letter, but of this integral here. And so then when at infinity, this goes away. At 0, I get minus 1/2. And so what I'm end up left with is, well, 1/2 times the integral from 0 to pi over 2 of just d theta, which is pi over 4. Okay, so I guess up here I left off the 2 when I should have had 2 here and 2 here, and so when I take this down through, I should have an extra 4, an extra 4, an extra 4, an extra 4, and I'm left with 4 pi over 4, or just pi. Or in other words, gamma of 1/2 squared equals pi, so gamma of 1/2 equals the square root of pi as promised. So there is the proof that I promised you guys. I hope this makes sense. I'm happy to talk to you guys about it in office hours or any other time. I hope this is helpful. Take care.